All right, 6.4, solving linear inequalities. And in this lesson, we'll just deal with adding and subtracting. So before we actually do the questions, let's do a quick investigation. So what happens to this inequality? Negative 3 is less than 5 if we add the same number to each side. So what number do you want to add? I don't care. Let's try, I don't know, 1. So think about it. Here's negative 3 after starting, and here's 5. We know that it's less than, correct? If we were to add 1 to it, this is our new value now, negative 2. If we were to add 1 to it, 6. It's still the same inequality. Negative 2 is still less than 6. Now, what about if we were to subtract? Okay, maybe we subtract by, let's say, 3 this time. So once again, starting with negative 3, let's subtract 3. So 1, 2, 3. Our new number is negative 6. Started with 5. We'll subtract 3. So 1, 2, 3. That's 2. Still, negative 6 is less than 2. So the above two ideas show the following property. If I were to add or subtract, it should be adding or subtracting, not subtraction. Adding or subtracting the same number from both sides of an inequality. And this key blank here is does not change the value. Okay, so that's nice because that means we just keep the sign the same. And really now to solve algebraic inequality questions, it's the same as solving regular algebra equality questions. Here's an equality question. H plus 5 equals 9. We would subtract 5 off both sides, right? So H equals to 4. It's the same thing now with the inequality. We'll just subtract 5 off both sides. H now is less than, well, what's 9 minus 5? That's 4. And that's our final answer. We can always show this on number line too. Remember, 4, no equal sign, so an open dot, less than going to the left. Okay, you're ready to try these now. So turn the page. Example number 1 is yours. Go ahead and now try to solve each of the following inequalities. Okay. So the opposite of minus 4, I'm going to add 4. M is greater or equal to negative 3. Solid dot at negative 3. Whoop, to the right. That's it. K plus 6 less than or equal to 7. Let's subtract 6 on both sides. K is less than 1. Sorry, equal to, so solid dot, whoop, to the left. Okay. Decimals, ew, but same idea. So subtract 5.8. D, I believe, is greater than 4.2. So here's my value of 0. Let's pretend this is 4.2. Open dot, because no equal sign, greater. Let's go to the right. This last one here, add 5.1 to both sides. 6.4 minus, or negative 6.4 plus, that's subtracting, so negative 1.3 is less than or equal to D. This one's interesting. Usually D are the variables on the left-hand side, and this is on the right. So if I were to rewrite this on the left-hand side, that means D is greater or equal to negative 1.3. And therefore, once again, if I draw this, oops, negative 1.3 is over here to the left of 0. I have a solid dot because there's an equal sign and it's going to the right. Okay. Now I could have two separate equations with the same variable. Okay, so it says determine two values of x now in example number 2 that satisfies both of these inequalities. So if I solve for x, we're going to subtract 6 on both sides. X is greater than negative 1. Over here, adding 5 to both sides, x is less than 3. So how do I show this? Bigger than 1. Whoop. Wait. It also has to be less than 3, so I better stop at 3 and just say the numbers in between. And that would be my solution. And ladies and gents, the equations below in example number 3, hey, they look very similar to what we did in 6.1, 6.2. Just now there's an inequality sign. So why don't you try to solve it yourself? Okay? It's just like solving equality. Subtract 3m. M plus 7 less than 6. Subtract 7. M less than negative 1. Same thing with b. I'm going to put the x's on the left side. X minus 8 greater than equal to negative 4. Add 8. Add 8. X is greater than 4. Greater than or equal to 4. Okay? Now, by the way, if you solve this one by moving things to the left, okay, so just let me make a quick note. Oops. Plus 5x. If you did this by subtracting 6x, negative 8 greater or equal to negative 4, 5 minus 6 is negative x. Then you added 4 to both sides like this, negative 4 greater or equal to negative x. Here's your dilemma here with this negative x. And then you divided everything by negative 1. You got 4 like this. Well, this answer is not the same as that. And I'd say this answer over here is actually wrong. And I'll tell you why by watching the 6.5 video. So go watch the section 6.5 video and you'll find out why this answer is not the right one.